So the very first thing you see up at the top here is just a refresher. This is not 2.5. This is 2.5 in our old book. Yeah, just put your screens down for a second. Not for a second, for a few minutes. So back, we did this not in 2.5 in our old book. They cover it in 2.5. In our new book, we did it in our prerequisites chapter. Do you remember how we talked about I's in September? Okay, so just a reminder that the square root of -1, today we're going to denote by the letter I. Square root of negative numbers, just a reminder, like if I saw the square root of -25, how could I write that as a complex number? What would that be? 5i. Okay, so today we're going to see some things that are complex again. The big thing that you need to understand is when you're finding zeros and they're complex, they always come in pairs. Always. So the imaginary ones are always going to come in doubles. So it's not possible to just have one answer with an I in it. If I tell you the one with an I, you got to know, hey, there's another one, which is kind of nice. You get a 2 for 1. Then you can find the second one. All right, so we already did that in the prerequisites, which is nice. Today, we're talking about how does that relate to finding zeros. So just understand the word complex zeros today. Some are real. That just means some are real and some have I's in them. So some are imaginary. When we put them all together, those are the total complex zeros when we put them all together. How do we tell how many zeros something has? Guys, this is going to be the easiest thing we do all day. A polynomial of degree n has n complex zeros. What? If I want to know how many zeros, you don't have to do any work. You literally put your polynomial in standard form and you list the degree. That's how many zeros it has. Some of them may be repeated. What do I mean by that? Do we remember seeing zeros written this way yesterday on our test? We called that a multiplicity of 2. That's what I mean. This counts for 2 of your zeros when you see that. Okay, this is not new. If a plus bi is a 0, the way you find another one is you find its conjugate, a minus bi. So they always come in pairs. Today we're going to factor again, and we're going to factor and we're going to stop when we don't have any real ones left. When we stop and they only have real coefficients, what you're going to get is linear and an irreducible quadratic. And you might be like, I don't know what that means. I'll show you. An irreducible quadratic means it's impossible to go any further without them being imaginary. In other words, you can't see any more zeros on your graph. That's what that means. What we're then going to do is one step further today, and we're going to go into linear factors, and linear factors are going to have I's in them. Okay, example 1, let's begin. So I tell you there is a polynomial. It has zeros of -2 and x equals 3 plus I. How many is that so far? Just tell me with fingers. How many is that so far? Okay. But I just told you imaginaries always come in pairs, right? And this one's imaginary. So now I know how many are there. 3. I'm going to go ahead and write that other 0. They're conjugates. What's the conjugate of 3 plus I? 3 minus I. So even though it's not written, I'm going to write x equals 3 minus I. So now, 3 zeros, how many zeros it has tells you the degree. What's the degree of the polynomial? It is degree 3. The reason why I say minimum degree is it's possible, like this is a multiple root. But I didn't say that, but it's possible. It could be more than that if that was a multiple root. Minimum degree 3. Would you write this in factored form? So this might look a little funny to you, and I don't know if you did this last year. You're going to have to tell me in a minute. Your polynomial, the first one, let's write the real 0. How would you write x equals negative 2? X plus 2. The way you write these are the same way. We write x minus the 0. So I write x minus, and I put this in 3 plus I. I use a parentheses around it because I have to subtract the whole thing. And the other one would be x minus parentheses 3 minus I. Okay. Who likes multiplying? None of you? I see no happy faces here. So I'm going to show you what an irreducible quadratic is. Well, what's the one word you know in there when I said that? Quadratic. So when you multiply in factored form the zeros that are conjugates of each other, what you're going to get is a quadratic, and the i's will disappear. Okay? So now it's going to be a little long, I'm going to be honest with you. Okay? So I'm going to multiply those two together out here. I am going to distribute this negative, so that becomes x minus 3 minus I. What would this become then? X minus 3. If I distribute that negative plus I. All right. I'm going to have a method to my madness. Some people like to multiply in different ways. I want to make sure I get everything multiplied in the first parentheses by everything in the second parentheses. So here's how I'm going to do that. I'm going to multiply this x by everything, and then this negative 3 by everything, and then this minus I by everything. So here we go. X times x is x squared. X times negative 3 is negative 3x. X times I, I'm going to write plus ix. Don't worry, in a minute those are going to cancel, the i's are. All right, now I did the x, now I'm going to do negative 3 by everything in this second parentheses. So I have negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times I is negative 3i. I'm almost done, guys. We're almost there. Finally, I have this negative I. I'm going to multiply negative I by everything in the last parentheses. I have minus ix. Minus I times minus 3 is plus 3i. And negative I times I is minus I squared. With your pen or pencil, would you find things that cancel and cross them out? in this list would you find things that are canceled? They are opposites, and cross them out. I see these two. That's good, because I really want those i's to be gone. Yuck. I have plus ix and minus ix. Those are going to cancel. I also see minus 3i and plus 3i. Can I cancel those two? Let's cancel those out. But I still have this. Oh, wait. I can do I squareds. What's I squared? -1. So this is really going to be minus a -1. In this spot, I am going to make that a +1. All right, let's go back to the previous letter. What was the first factor, the nice one? X plus 2. We call that a linear factor because it's degree 1. So I asked you to write it in as a linear and irreducible quadratic. My linear, I'm just going to drop down from here. It is just x plus 2. And my irreducible quadratic is my new quadratic. If you multiply correctly, the i's should be gone. You're going to know you did it wrong if you still have i's in your answer. And then you're going to come see me and say, what did I do wrong? We have x squared minus 6x, and plus 9 plus 1 is plus 10. So this is my linear right here. And this is my irreducible quadratic right there. Just means that if you tried to solve it, you would get imaginary answers, and we already know what they are. We just went forwards.